coffee break. The next section of the workshop begins now. We are honored to have Professor Chris Terman as our second MIT speaker. Professor Terman is the Director of Academics, MIT Ethics, and Senior Lecturer in the MIT Department of Electrical Engineering and Computer Science. He has 4 decades of experience as a teacher, digital system designer, courseware developer, and entrepreneur. Professor Terman's research has been in the areas of programming languages, compilers, and computer-aided design tools for integrated circuits. Most recently, he was the research director of the MIT Cumulus Education Project, a research collaboration with Quanta Computer Inc. focused on the development of cloud-based educational technologies. Professor Terman received his BS in physics from Wesleyan University and headed to MIT for graduate school in 1973. He completed his MS, EE, and PhD degrees in computer science and engineering and subsequently joined MIT's EECS faculty. He escaped from MIT in 1985 and tried his hand at being an entrepreneur before returning to MIT in 1995. He's an avid hiker and enjoys guiding summer walking tours in the Swiss Alps. The title of his talk is See One, Do One, Teach One. Professor Terman, please.
Thank you. I'm glad to be here today. It seems we have many shared interests, and I hope over the next couple of days we'll get to explore those further. A few years back, we were invited by the chairman of Quanta Computer, Chairman Barry Lamb, to think a little bit about how computers could be used to make education more effective. And we sort of rolled up our sleeves and began to think a little bit about what were the places that computer technologies might have an impact on the world of education. We've heard a little bit about self-paced mastery learning. That's sort of the gold standard for group education. It does almost as well as a one-to-one individual tutoring if it's done right. My particular interest is in the world of hands-on learning, active learning, getting students to actually build things, which I think is the way I like to learn how to do stuff, and I like my students to do the same thing. I think computers have a chance to really provide wonderful environments for doing both of those things. In business school, they teach you that you are what you measure. In other words, if you can't measure it and see what's going on, you have no way to improve on the system because you don't have any information about sort of how the system is working so far. So the MOOCs offer us really our first at-scale educational laboratory where we can propose experiments and perform them with hundreds of thousands of students. And that's really quite remarkable. For a scientist or an engineer, that sort of ability to do educational experiments means that we'll be able to measure results and actually target improvements for the first time. In the area of interactions, so much of educational material is in natural language. And so we have forums, we have book chapters, we have audio-visual materials. Processing those so that they're accessible to the world of search and summarization is something that we've had a long-term expertise. Professor Zhu will talk about a little later today, about using human language technologies to make some of these new types of interactions accessible to students. Online, we have an interesting issue of how to build learning communities. And in particular, how to engage learners to help one another in learning. If all of us who have had a chance to live in college dorms know that a lot of our learning happens because somebody down the hall could interact with us and explain what is going on. And I think that how do we create those sorts of environments, perhaps asynchronously, in the world of computer education, online education. Finally, there's a lot of types of new content that it takes a lot of work these days to author an online course. I've worked on 3 over the last couple of years, And it's a labor of love. And we need to make that much, much easier for people to be able to contribute material, learning, teaching material in some of these new frameworks. We have to make that a much lower bar so people can clear that hurdle quite well. One of the things that is interesting when you're setting off to think about how to construct educational materials is, what is your philosophy of education? In other words, how do you think people learn, and then how are you going to structure your materials so that people can learn that way? And I like to borrow the phrase from medical school: see one, do one, teach one. Initially, your first job is to, if you're sort of a novice, you need to learn the concepts and observe, things being demonstrated, techniques and skills being demonstrated. You often get your first handle on how things are put together by analyzing things that already exist. A particular mathematical proof, a particular medical procedure. These are things that you sort of figure out why they worked, how, and things like that. So your job as a novice is to understand what is going on. As you progress, you get into the do one category, and this is to use so novice, apprentice, master is sort of the language of the guild halls in Europe in the Middle Ages, right? So how did somebody learn a trade? Well, they went through these 3 steps. So the apprentice step is that you're for the first time actually taking the concepts and skills and you're using them yourself. Rather than watch them happen, somebody else do them, you are for the first time saying, oh, it sort of looked easy when Steve did it, but now that I'm doing it myself, is actually, it turns out to be a little bit harder. And so maybe for the first time, you're actually creating things. So rather than analyzing other people's artifacts, you're beginning to synthesize your own. And so you begin to realize how things are worked. Because you're putting them together yourself, you know how they work. And then finally, at the mastership level, your job is to teach these concepts to other learners. And in fact, as you'll see a little later on when I talk about teaching teaches the teacher, teaching is actually something that we don't actually ask many students to do now, but most of us who have done a lot of teaching sort of appreciate how much better we understand the material because we've had to sort of organize it and make it accessible to people and explain why things are the way they are. And I think that, if you looked at Steve's sort of spectrum of levels of understanding, I think explaining why something is true is actually pretty high up in my list of, if you can do that, then you probably have a very clear idea of the concepts from soup to nuts. Okay, so how do you design an effective learning sequence online? Well, the current favorite recipe is basically short videos followed by interaction. So it's a little hard to see here. This is an edX page. There's a bunch of video segments, and then occasionally there is an opportunity to stop and ask fairly simple exercises just to have the student engage in the material. So we're all sitting here patiently listening to lecture. But what would be really hard is, not hard, but what would be great if there was a way in which you could stop and do a little bit of interaction every 5 minutes or so. Your concentration level would go way up. And in fact, one of the things that we experience in the flipped classroom is exactly that sort of effect. So we keep doing this. So what used to be an hour lecture is now a whole set of very small video sequences with opportunities for the students to actually do a few simple exercises after each concept is introduced. One of the things that we don't really pay a lot of attention to as classroom lecturers is what people should do with their eyes during an online learning experience. Right? What happens is, as soon as there's motion on the slide, you are watching that. We're visual beings. We're trained to watch things that move. In a lecture hall, I'm here moving, and so you're watching me. You can't really help but to watch me. You're physiologically built to watch moving things. Over here, on an online thing, it can be deadly dull to watch one PowerPoint slide sit on the screen for 10 minutes while somebody drones on. Right? So the question is, how do we, as teachers, we have to start working on creating materials that are much more lively in that sense. And the reason is that we don't have a captive audience. In other words, somebody who's watching our stuff online can quickly go do other things online. So what you want to do is to make it so interesting that they really want to hear the end of that story. Right? And that's a challenge because we're mostly used to people who, you're trapped here for the next 20 minutes. So, if I'm a little boring in a piece of it, you're not suddenly going to click away and you'll never see me again. So, Here's some interesting data. So we're starting to get some data back from some of these courses. If we look at this thing about what people watch videos, you can see up to about 6 to 9 minutes, most people watch the whole video. However, if you created a 40-minute video, on the average, people watch 4 minutes of it. Okay, so that's, on the other hand, and here I am, I'm a practitioner, like you probably know, the hour lecture, right? And I'm suddenly realizing, wait, 4 minutes in, most of the students have stopped listening. That's not so good. So the idea here is we're beginning to get some idea of how people engage with the material, and we want to shape our material a little bit to sort of match up with how they're going to engage with it. Our big goal, or one of our big goals, is to achieve mastery learning. And mastery learning is the idea is you're going to work on a concept until you've got it. So, here's the standard bell curve of distribution showing, the grade distributions in a sort of a standard class. Our goal is to take the people who don't do so well on those assessments. And it wasn't that they're dumb, okay? It's just that they didn't get that particular concept in the 5 minutes I talked about it. What we want to do is to take those guys and basically figure out how to let them at their own pace master the material, and hopefully, collectively we'll all do better. So the good students are okay. What's hard is the students who didn't capture a concept before we moved on. The trick is not to move on before they do that. One of the challenges is coming up with assessments that help people judge their mastery. And in fact, you have to come up with many assessments because they want to, they didn't get it the first time. They want to come back and see a new question to see if they have mastered the material. And so one of the things that we've been working on recently is creating adaptive hints. The CMU had a great project, the Online Learning Initiative, which really pushed these, and we're starting to put these into the platforms where, depending on how you got the answer wrong, we will tell you something, we'll have a hint that's specific to that answer. So I can look at all the wrong answers for a particular question and start developing hints for people who got particular classes of wrong answers. So a key to mastery is not whether you got the answer right or wrong, but when you got it wrong, somebody tells you, maybe you forgot to think about this. So we're trying to make the online platforms do a better job of that. The big problem with self-paced is that it's hard to basically keep people moving along. If I can do it any time I want, maybe tomorrow is when I want. Today, I'm busy. And we all face that. We all have busy lives. And so deadlines are actually, everybody goes, oh, deadlines. We shouldn't have deadlines in self-paced. But deadlines are what most of us respond to in, figuring out what we have to get done today. So trying to think of a way to introduce deadlines into a self-paced program, it seems a little bit of an oxymoron. But I think we can sort of build individual deadlines based on watching a student work. We can guess how long they should have for the next segment. Okay, so if we watch this guy, he's busy trying to type in a bunch of answers to figure out the thing. He doesn't know where that 2 goes. Which part of the chemical equation should that 2 go on? And he's basically, by sort of fooling around, he gets immediate feedback. So rather than writing down a P-set answer, and then coming back a week later to just a problem set, I'm sorry, we call them P-sets where I come from, coming back a week later and getting the graded homework, you can find out right away whether it was, you have the right concept or not. So this immediate feedback is very good. You have to be careful, though, that we don't get into this guess and check, loop. And it's funny, I can replay, the students in sort of real time. I can look at the logs and replay what they do. And you can see students who are guessing and checking. 3, check. 4, check. 5, check. They're just trying to find out what, I just want to get the green check mark, thank you. We need to figure out ways to avoid that in this sort of strategy. So immediate feedback is very positive. People really love the power the feedback gives them to judge whether they know the material, but the flip side of that is that people get so focused on, do I have the right answer, that they don't really, they're not putting the time in to learn, they're just putting the time in to guess, which is not our goal. Here's the part I really love. I think Craig and Lonhart said it really well. The learning and retention is related to the depth of the mental processing. So how do we get deep mental processing? right? How can I get you all to be, doing deep mental processing right now? And the answer is I would have to give you probably a hands-on activity, right? Listening is often not a deep thing. Sometimes it's thought-provoking. Sometimes the lecturer is energetic enough that you're at least paying attention. But these sorts of hands-on activities are all different ways to engage different aspects of learning. So in this thing here, the idea of sharpening your intuition. So many scientists and engineers, they're very smart, they know about all the mathematics, but the key to innovation is having a good intuition of about how things should work. And sure, you might have to use math to get the right answer, but it may be in something like this. If I had told you, for example, what would it take to get the electrical field vertical right at that point? Right? And now you'd have to start thinking a little bit about how do I place the charges? How does the electric field, in sort of general terms, how does the electric field formed by the charges? And now I'm getting you to think about what I want you to think about, right? And so it's not only just something to play with, but I give you a little challenge to go on with it. And all of a sudden you're experimenting, right? You're being a scientist. You're beginning to try to feel about how things should work. So sharpening your intuition is an important part of hands-on. Another important aspect of hands-on is muscle memory. We've all learned that if we take notes, I'm down here in front of the audience taking notes, not because I'm going to spend a lot of time referring to those notes in the future, but the fact that I'm writing them down, particularly the points that really appeal to me, that's the thing that will cause me to remember it. And so this notion here of there are certain tasks that if you use your muscle memory, like crumbing up with these chemical structures, if you actually involve you're moving your arm, or in this case your mouse, to put things together, you will remember that chemical structure in the future. I can show you lots of slides of chemical structures. It would have no impact. If I tell you to draw them yourself, you will remember it. Right? So coming up with hands-on exercises that let us exercise our muscle memory is, I think, an important thing. Here's the hardest part of hands-on, starting with a clean slate. Right? I teach a course that teaches this material, and this is some student visibly working away on creating a particular circuit that has a particular functionality. But starting with a fresh piece of paper where you have to decide, what do you do first? What do you do second? How do I know I'm doing the right thing? Organizing the drawing the way that it makes sense, that you can see that it's right, that it's not just a garbled mishmash of gates. And so it's this sort of design activity that most students identify as really being there. We talk a lot about logic, but there's nothing quite here. Got the bug. There's a bug in his circuit. He's going to have to fix it. They're, for the first time, able to actually feel like engineers or feel like scientists or something like that. So the idea is we're giving people a chance to actually exhibit the behaviors we're trying to teach them. And so that's a very powerful reinforcement. Okay. The challenge in these sort of online environments is how do we give over-the-shoulder help? You're having a trouble with this circuit. How can I, as an instructor or one of your peers who's finished the problem successfully, look at what you're doing, right? And so, we already have some solutions in hand, right? Google Docs allows all of us to share the same document. Well, we want to bring that technology to all the sorts of online interactions here. So it's possible for people to collaborate in a shared space like we would if we were sitting next to each other, at a desk in a dorm. Now we can collaborate online in much the same way. And we have those tools. They're just getting them onto these systems, into the educational platforms is an ongoing challenge. Okay, teach one. We don't often ask students to do much teaching. You just have to learn and do, or see and do, and then you're done. I think that asking people to teach is super important. So here we have forums in which there's a small class of students who clearly have invested a lot of time in coming up with very good answers to questions. And first of all, it's nice to go and find those students and say, I want you to be a teaching assistant for my course, okay? But more importantly, a student who is able to generate that sort of answer clearly understands what's going on. And my guess is that in the process of writing that, maybe for the first time, they actually organized their thoughts and they were able to articulate them in a way they never bothered to
for themselves, right? It's funny when you start talking to other people, now you're putting them in a rational thought, whereas they're sort of jumbled inside your head. Now they're organized. So this sort of thing is super, super great, and we need to be able to make this as much a part of you taking a course as you are, you're doing the homeworks. Of course, the challenge is how do we do this with all the people taking an online course? The forums are a real mess, tens of thousands of posts. How do we come up with a way in which smaller groups of students can have meaningful interactions with each other, some sort of cohorting strategy? Do you have a question or no? Oh, you're just, yeah. Okay.
So you seem to be assuming that the ability to organize knowledge well can be taught to a large number of people. Does that match your teaching experience with this?
So I think some
people just do that
right.
naturally.
Some people do it naturally, and I think if you can do it naturally, more power to you. But I think if you watch other people, so if you watch me organize the material for somebody, after a while you'll be able to basically channel the inner Chris, right? And I think I've seen students who've only done a mediocre in my course come back and be excellent LAs because they started to internalize how to explain things to people. And in the course of doing that, they learned how to explain it to themselves. They actually mastered the material through teaching more than they ever mastered it through the actual learning process themselves. We have a system where students are able to add hints about things that are going wrong, particular tests. And so students can go look up. They can say, I'm having the same bug here. Maybe I can go get a hint as to what's wrong. And the students are very good about the hints. They try not to give away the answer, but they try to be constructive about things you might go look at. So I think that's turned out to be a very powerful tool for students to help each other. And I think Rob will say more about that a little later on learner sourcing. Towards the end here, reflect and advise. So one of the things we don't often do is once you've finished your answer, we don't ask you to think about it much. You say to work, what do I have to think about? Well, here the students, once they finish their answer, are showing designs that are both worse, that have, in this case, a bigger size than the one they designed, and also one that has a smaller size than the one they designed. And they were asked to give advice. What would you tell students who had done worse than you or had done better, and what would you tell yourself to be able to get the best design? So we're actually getting them to think about how they could have done better. What does better mean, and how would you explain to somebody how to do that? And so we get these great comments coming back, and so the reflection is not only good for the individual student, but now we can start use these as hints for people who are having problems in doing the design. If we look at an online course, how do students invest their time? And you look here, this is the data from an electronics course that was taught on edX. It was the first edX course that I had the honor to work a little bit on. And you can see that certain activities are pretty constant. The notion of spending about 2 hours a week watching lecture videos, and there were 2 hours of lecture videos to watch each week. So you're saying, wow, that's just exactly what I thought. There's other things here which actually sort of go, wow, look at that homework. See the homework really drop off toward the end? Why was that? Right? There must be something about those later homework problems. That maybe people just were maxed out and couldn't put in the time. So being able to measure how people are using the materials turns out to provide the teacher some insight into what repairs they need to make to the course in order for the right thing to happen in terms of outcomes. What's interesting to me is there's certain things here that we thought were important, like the book. There's actually a Elsevier textbook that goes along with this course, which turned out to be not very referenced at all. And you're sort of going, oh, God, I would have thought the book would be much more important. So we're getting a sort of a sense now of what users really think is important rather than what we as teachers think is important. We prepare many, many different materials, right? We have online lectures, we have the lecture questions, we had labs, we had homeworks. How did people engage? So the charts on the right are sort of show you what percentage of the people who finally earned a certificate, how much of those they did. For instance, you look and you can see there about 3% of the people who finally earned a certificate watched 83% of the videos. More interestingly, so some of these things you can see there's bumps in. Other things are pretty uniform. In other words, people, and so lines that basically go from the upper right down, the upper left down to the lower right is basically a fairly uniform distribution of people who are equally divided about how much of the resource they used. Lines that stay high are material that were used by everybody almost 100%. Those seem to be the materials you'd want to emphasize, right? So those are the ones that say, wow, I've hit a sweet spot there. Let's do more of those and less of some of the ones that no one bothered with. It's interesting to see how people are assessment-driven. This is not really much news. The circles show the amount of time they spent. So on an average homework, on the midterm exam, on the final exam, you can see the final exam was about the time they spent on it was about twice what they would spend on a homework. But then you see why they were doing that. What did they go look at? Right? So they can go look at all the online materials. And you think we're giving lectures, right? We say, wow, lectures are so central to the course. Lectures don't rate very highly as the go-to resource when somebody has a question they need. I don't know how that works. What's interesting is that the discussion forums and the homeworks and the labs tend to be the places people go and says, that's where I saw that. I'm going to go look at it again there. So we're starting to realize that maybe what we should do is reorganize things a little bit to give people the problems they need to solve first, and then give them the materials they need to solve it. It's sort of fun to think about how to reorganize teaching. And let me just finish by this. I was resonated with the earlier talk by the dean about the importance of teachers, right? It turns out that about a quarter of the certificate earners in edX, okay, are actually teachers who are teaching that subject. Right, and what they're doing is, it's interesting to speculate why it is they're engaging with the online course. They know the material. Some people are just trying to say, I'm just checking to see if I still have all my skills. Maybe they're looking for new material, right? Maybe they're trying to say, is this presentation better somehow? But I think there's a real opportunity here as people who are putting stuff online to actually focus on what this huge cadre of teachers would find really useful. Okay, in terms of things they could find online that perhaps they can adopt and use in the courses. So let me just finish up by saying, look, we have a lot of exciting things happening online. We get to re-engineer so many different aspects of the educational experience as we move it online. I think that we're discovering that the most effective types of online materials are not simply the repeats of what we've done in real classrooms. Maybe that doesn't surprise anybody. But it's a fun adventure to start thinking about what we should do in the future that's so different than what we've done in the past. Thank you.
Thank you, Professor Thurman. The next talk will be presented by Professor Chi-Yu Chill, Dean of Faculty of Social Science, CHK. Professor Chill is an internationally renowned